Alright guys, welcome to your 39th chemistry tutorial, and in this video I want to talk to you guys about rate of reaction. Now rate of reaction is important to understand because first of all, it's important to understand why some chemical reactions happen fast and some other chemical reactions happen relatively slowly. And it's important to understand that because say that you want to start cooking meth in your bathroom. Well, if you have a bunch of meth users or meth heads outside your house being like, dude, we want our meth, hurry up and, make it already. You want to be able to speed up the chemical reactions, so you need to understand the factors that contribute to the rate of reaction. So in this tutorial, I'm going to be basically teaching you guys how to make meth faster. Well, not exactly meth, but any chemical reaction, the different factors to contribute to how fast or slow that reaction occurs. So the first thing I want to do is I want to talk about the first factor. Oh, sorry, got freaking phlegm in my throat. It's going to be annoying all tutorial, but, I guess you guys got to deal with it. And the first factor is basically the size. I'll put size dash complexity. And I don't mean complexity of the entire reaction, I mean the complexity of the molecules themselves. So say that, for example, we have, well, just remember this. Whenever a chemical reaction occurs, there must be a collision at the reactive site of the molecule. Now, obviously for a large and complex molecule, there is a less chance just due to the nature of the molecule that it's very big and complex. So what am I talking about? Well, say that you have a molecule like X and it's bonded to A. Well, A bonds with B, just like that. So if you have these two molecules right here, XA and B, obviously B has a good chance of bonding or colliding with A. Alright, makes sense. Now say we have another molecule, let's do this. X, X, put a couple more Y, 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 X, and these of course, would be some kind of element. X, and then we have our A right down here. Again, there's our A in the bottom right. So this obviously is a very large and complex molecule, and then we have our other chemical or element B floating around. Well, check this out. B doesn't have a very good chance of coming into contact with the reaction site because this molecule right here is a very large or complex molecule. As opposed to this molecule, it basically, if it hits it has a 50-50 chance of reacting. But with this one right here, since the molecule is so big and so complex, then B is going to have a very hard time hitting the reactive site, which is A, which is pretty much the sweet spot on the molecule that needs hit in order for a chemical reaction to occur. So basically, the larger or more complex the molecule, the less chance of collision. Now, another thing that I want to talk about is particle size, or it may be better if I put surface area. That may be a little more clear to understand. And the best way to, kind of talk about this is to give you an example. If you go ahead and you took a large chunk of coal, we'll say that this is coal, and you pretty much took a match. Let me find a good color for a match. So here's a match right here, and let me get my little yellow flame. Wow, that's the worst yellow ever. I'm gonna fix that. Alright, so here's a match, a beautiful looking match, and if we held it up to a chunk of coal and we, obviously we had the match lit, nothing is gonna happen. Why is this? Because you're only hitting a very small part or very few amount of particles, a very low surface area. Now if we took that same piece of coal right here and we grinded it up so it was basically no longer one big chunk but a lot of fine powder, and we basically tossed it in the air, and then we took our match, which is evidently black now, and we lit it on fire, then do you know what would happen? Well, in that instance you would actually get an explosion. So the same molecule right here, the same chemical that we can say, it just is in a different form. This is one solid chunk and this is finely ground powder. So why does this chemical reaction basically not occur at all or happen really slowly, while this one right here happens almost instantaneously. Well, the reason is because particle size, or more, maybe it's easier to say surface area. When there's more surface area, basically there's more space or more particles that the chemicals can react with. So that's basically why not only the nature or size or complexity of the molecules is important whenever we're talking about rate of reaction, but also, as we demonstrated in this example, the surface area, or how many particles the chemicals have to react with.